411 years ago, when Galileo observed Jupiter for the first time, he may not have imagined someday we'll be visiting there. Being the largest planet in our solar system, Jupiter has the most influence on everything else. So, to understand the past of our solar system and how all the planets formed, we have to study Jupiter. By studying this giant planet, we may not understand how life on Earth formed, but how all the elements that made life came into existence. When looking at Jupiter, even with an amateur telescope, we could easily see how Galileo would have seen. If you peep through a telescope, you'd notice a giant red spot on the planet's surface, but not the same as Galileo would have seen. Now we know it's actually a storm, just like storms on Earth, but a storm of denser clouds. Though we have been watching Jupiter for centuries, we never looked inside the giant red spot before just now. Scientists looking at the spot has noticed it changing over time. They noticed the color deepening and size shrinking into a round shape. Naturally, that must mean the wind speed inside the red spot was increasing. But that was not the case. Data revealed that the spot, instead of getting faster, is actually getting taller. You can think of it like working with pottery. As the white lump of clay spins, the forces within are driving it taller. So from our perspective, looking down at the clouds, we see the spot getting smaller and rounder. The spot once could have engulfed 3 Earths, but now the size is just big enough to fit one. Visiting Jupiter is not easy. It has a very strong gravity. But Juno, during its 2019 pass over the Great Red Spot, had to face another challenge. Though the Juno spacecraft buzzed the planet at 130,000 miles per hour, the storm is so massive that its gravity field jostled the spacecraft during its flyby. The local gravity tends to pull and push away the spacecraft as it flies over the vortex, and this creates a sort of like bumps in the road for Juno. With gravity, radiation is also a big problem when it comes to Jupiter. We here on Earth are exposed to background radiation of just a third of a rad. But in Jupiter, the background radiation is about 20 million rad. So, flying in these gravity bumps and extremely high radiation is tough. In Jupiter's north equatorial belt, Hubble imaged an elusive wave that had been spotted on the planet only once before, decades earlier by Voyager 2. In Voyager's images, the wave is barely visible. Nothing like it was seen ever again until the recent Hubble observations. In the Hubble images, the wave appears as nearly vertical lines passing through the top of the dark central cloud belt. The wave was found traveling in a region dotted with cyclones and anticyclones. Similar waves, called baryoclinic waves, sometimes appear in Earth's atmosphere where cyclones are forming. The wave may originate in a clear layer beneath the clouds, only becoming visible when it propagates up into the cloud deck. This is how Voyager 1 saw Jupiter. The white spots on Jupiter can come and go. They evolve for reasons that still aren't fully understood, and the dark spots near Jupiter's equator, like the ones shown here, may actually be cloud-free openings in the atmosphere. But the giant red spot is deep. The storm is between 300 and 500 kilometers deep. Juno spent 5 years traveling through space, and the vehicle inserted itself into a very wide orbit around Jupiter, one that would take Juno very close to the planet every 53 days. During these close passes or perijobs, Juno has collected the majority of its data about Jupiter and what might be lingering inside the gas giant. During these passes, Juno measured the spot's gravitational field in an attempt to figure out just how deep the storm goes. That gives an answer to the big question but raises more. The red spot is 500 kilometers deep, but some of the surrounding jet streams extend up to 1,800 miles or 3,000 kilometers into the planet. Juno also helped to pinpoint those measurements, and scientists aren't sure why there is a discrepancy. Scientists think something is happening at 500 kilometers that is basically dampening the Great Red Spot. What could it be? Could it be alien life that somehow has learned to control the storm? Or it is some solid object that is creating an elevation making the storm smaller? That means there is still more to learn, and I shall let you know if you subscribe and hit the like button.